Good morning. I'm Javed Ali, professor from the Department of Information Technology, St. Joseph Institute of Technology. Today, I'll be sharing some basic concepts about networks, followed by the model that is network model that is used in our internet. So, first we begin with networks. So, coming to networks something that are interconnected, or when an entity is when entities are interconnected, we refer to them as networks. So, coming to computer networks, so computer networks something the computers interconnection of autonomous computers. So, these computers should be capable of sending and receiving messages. So, any computer that is connected that can share information can be regarded as a entity in a computer network. So coming to communication, the what is being communicated across the networks is the information data. So you can see on the screen a diagram showing a message that is exchanged between two parties, sender and receiver. So what makes up a successful data communication? So or what are the parties that are involved in data communication? So for a successful data communication, we require a sender, a receiver, and information that is being exchanged, that is entity number 3, and then a medium upon which the exchange will take place, hardware base, and finally the set of rules that govern the communication. So totally there are 5 entities that govern a successful data communication: sender, receiver, message, medium, and protocols. Okay. And coming to the characteristics of data communication, so we have four characteristics that make up data. Okay. That make up a communication. Okay. First thing is the delivery. So whenever we want to communicate, we need to know the opposite side to which we are to whom we are communicating. Okay. So the message that is sent by a receiver should be received. The message that is sent by a sender should be received only by the receiver, and none other than the receiver should receive that message, right? And coming to accuracy, so accuracy involves the format in which the message was drafted by the sender. In the same format, the message should be received by the receiver without any modification to the data. That is integrity. We have to maintain the integrity of the data that is exchanged between the sender and the receiver. So that's what is accuracy is. Next comes timeliness. So data communication is bound by time. So whenever a sender sends a message to a receiver, the receiver should be receiving that message within a stipulated interval. Okay, so that's what is timeliness is. And next comes jitter. So coming to jitter is data is sent in the form of packets. So when data is sent in terms of packets, the each packet should have a uniform interval. When that uniformity is not maintained, then it will have abrupt consequence on the data. Okay, for example, when you are viewing a real-time, event, and if suppose the data packets that are transmitted are not uniform, so how it will look like on the screen when you view that information is, for example, the audio of the event and the video of the event will not sync. Okay. And then there will be a broken screen. Okay, so these are all the consequence of jitter. Okay, so if the uniformity among the packets is maintained, then there will be no jitter. If there is no uniformity among the packets, then we say that jitter is said to occur. So we have to avoid that jitter. Okay, so data, how what can be referred as a data? So we can say data. There are various formats of data like text, readable format, numbers, audio, video, image. So these are all the various formats of data. Okay. And next we'll see about the direction of data flow. So one particular direction is referred as simplex. So what do we mean by simplex? When we have a one-way transmission. For example, a person communicates or speaks, the other person listens. Okay, so such type of communication is called as one-way communication or simplex communication. The best example is the exchange of signals between your remote control and your TV. So your remote will send the signal and your TV will receive the signal always. So such type of communication is called as simplex communication. And next one is half duplex communication. So coming to half duplex communication here, both the parties can transmit data, but not simultaneously. So when a sender sends a data, a receiver can only receive. Similarly, when the role gets changed, that is, the receiver is now acting as a sender and it is sending the data, the receiver, that is the sender, now will act as a receiver and it will receive the data. Okay. So non-simultaneous transfer is called as half duplex. Example is walkie-talkie, where one person will communicate, the other person will listen, and when the other person communicates, the opposite side will listen. So this type of communication is called as half duplex communication. And finally, the last one is full duplex communication, where the communication channel will be shared between channel is nothing but the path between the sender and the receiver upon which the data will travel. So in full duplex communication, the channel capacity is shared between the sender and the receiver. uh, Both the parties can transmit simultaneously, okay, and receive simultaneously. Best example is telephone, where one party will talk simultaneously, it will listen what the other party speaks. Okay, so it's an example of full duplex communication. And coming to the type of connections between the parties, we have two types of connections that can be created between the communicating parties. The first one is the point to point connection, where there will be an exclusive connection between the sender and the receiver. Coming to the other type of connection, which is multi-point connection, where we have a shared connection between the sender and the receiver. So it is shown in the diagram. So if you see on the left side, bottom left, we have multi-point communication, sorry, point-to-point communication. An exclusive link is established between the sender and the receiver, where only the data pertaining to the two parties will be exchanged. And coming to the right side bottom, we have a multi-point communication, where we have a backbone cable. From the backbone cable, individual connections are drawn. Okay. So here the capacity of the backbone cable is shared among the computers. And coming to the topology, so topology is how the network is laid out. Okay, it shows the geometrical relationship between the links and the connecting nodes. Links are nothing but the cables. Connecting nodes are nothing but the computers. Now, there are four types of topologies that are present. So first one is the mesh topology. So coming to the mesh topology, here each and every computer will be interconnected to the other computer. For example, if there are five computers, all those five computers will be connected among themselves. Okay, so to find here, we may be asked to find out the number of links that will be required given the n number of computers. So the formula that will be applied will be n into n minus one. So n will represent the number of computers. Okay. So when you perform n into n minus one by two, you'll be getting the value that will be equivalent to the number of links that will be required to establish the mesh connection. And to find out the number of input ports. So number of input output ports. So if there are five computers, for one computer, n minus one number of ports will be required for establishing the communication, for establishing the connection. For example, for n is equal to 5, so 5 minus 1 is equal to 4. So for a single computer, 4 ports are required to connect with the remaining 4 computers. Okay. So if you see the advantages and disadvantages, here the setup of the network is very simple. Fault isolation and fault detection is very simple. Each link will not be disrupted by the traffic in the other link because it is a non-shared exclusive link. So coming to the drawback is cost. When you increase the number of computers in the network, the number of links required, number of cables required will also grow according to the number of computers. Okay, so the space occupied by the cables will be more than the actual space occupied by the computer. Okay, so usually because of this reason, these mesh networks are not preferred for larger networks. Next type of network is the star topology. Next type of topology is star topology, where each computers, when they want to communicate, they pass the message to the hub. The hub will relay the message to the destination. So, meaning which there will be no direct communication between sender and the receiver. All those computers that want to communicate, they have to pass the information to the hub. The hub in turn will pass the information to the destination. Okay. So here, if you see the number of cables required when compared with mesh will be lesser, even though it will be more. Okay, but comparatively it will be lesser, and fault isolation and rectification will be very easy because it involves only a single link between the computer that is faulty and the hub. So easily we can correct the computer or the fault. or the link fault. Okay, and a major drawback is the single point of failure. So if suppose the hub which acts as a relay between the computers goes down, entire communication will come to a standstill. Okay, so next topology is the ring topology. So coming to the ring topology, as the name suggests, the topology will be in the form of a ring. Each computer will have a forward connection and a backward connection. So a computer will be connected to it will have a predecessor and a successor. Okay, so communication will take place either strictly in one direction only. So direction has to be decided at the beginning of the data transfer. Either it can be clockwise or anti-clockwise, so which can also be considered as a drawback. And if suppose you are going to transmit from the first computer to the last computer, and if the network comprises of 100 computers, then the message when it reaches the 100th computer will be disrupted, because the disruption may be caused by heat in the network. Okay, and because of this reason only, the rings are considered, ring network will comprise of smaller number of computers, not more. And also if the ring, if it breaks in between, there will be no communication between either side of the ring. Okay, so that is a drawback. So next type of topology is the bus topology. So if you compare bus topology with the other topologies, just what we have seen, bus topology falls under the multi-point communication or multi-point connection, and the previous three topologies what we have seen, mesh, star, and ring, are point-to-point connections. So here in bus topology, there will be a backbone cable. So from the backbone cable, individual connections are drawn. Okay. So and again here also, the because of heat factor, the message that is transmitted between the first computer and the last computer will be disrupted because of heat. And if the cable is broken in between, communication cannot be established between either side of the cable. These are the drawbacks. Okay. So these are the four topologies that are available, right? And next we go for the classification of network based upon size. So if you see, we have three major classifications of networks based upon size. The first one is the local area network, so which will span for a few kilometers. A local area network can be created within a building or across the building within the geographical scope. So this diagram shows within a building, and this diagram shows across the buildings within a geographical scope. So if you see, different types of topologies can be constructed in each building, and these topologies of networks can be connected together, and they form a local area network. Mostly local area network will be owned by a single entity. Now comes the second type of classification, which is metropolitan area network. So in or shortly abbreviated as MAN. In metropolitan area network, the connection of the network will cover the entire city. The best example of metropolitan area network is the cable TV. Okay, so you can see different types of networks are there. All these networks are combined together. Okay, and coming to the last category of network, which is wide area network. So wide area network will span across the entire country or across the continents. Okay, so it is usually owned by multiple people. Okay, at each region, and they have to follow certain rules and regulations and policies based upon which the data transfer will take place. Okay, so if you see, it spans the entire world. Okay, so such type of communication is called as the network classification is wide area network. And coming to the next topic, that is protocol layering. So we know what is protocol. Protocol is set of rules. So these rules are mandatory for successful data communication. And coming to the layers, so layers where we divide the task of communication into different subtasks. So each subtask will be assigned to a layer, and each layer will carry out that subtask only. Okay. So on the contrary, if the entire communication is carried out by a single entity as a single task, the it will be complex, and finding out fault and rectifying the fault will be very difficult. On the contrary, if you have the entire transfer task divided into subtasks, so each layer will perform a specific subtask only. If any fault occurs, easily we can find out which layer has faulted, and accordingly we can go for rectification of the particular layer and particular task subtask. Okay, so that's why layering is preferred. Okay, so if you see the protocols, when two conditions communicate, so they do not communicate directly. Usually, there will be some intermediate machines that will be involved in between the sender and the receiver. Okay. So, how many protocols will be involved when you in a particular data transfer? Okay. So, for this question, Let us consider this diagram. So here we can see the source and the destination, and the source and destination are interconnected by some intermediate machines. So if you see the protocols layers, the source and destination will involve all layers, okay, and the intermediate machines will involve only those layers that are sufficient for the performance of their task. So if we consider the intermediate machines as shown in the diagram, switches and routers, they perform only, I mean, transfer of data, forwarding of data. So for forwarding a data, it is enough if we take into consideration of two layers or three layers, nothing more than that. Okay. So in the intermediate machines, only these layers will play their part and not all the layers. Doesn't mean that these intermediate machines will have only these two or three layers. They will have, of course, all layers, but among those layers, only these layers will be involved in forwarding. Whereas coming to the sender and the receiver, all five layers will be involved. All layers will be involved. Okay. So coming to the policies of protocol layering, so for our principles. So what the first principle states is that whenever a sending at the sender side, a particular activity is being performed. Okay. So it is interpreted on the opposite side of the at the destination machine, and the particular entity on the destination machine will perform an opposite task of the opposite. For example, on the sender side, a sending operation is being performed. On the opposite side, receiving operation will be performed. Send, receive, opposite. Okay. So next thing is the next principle. What it states is that so the object that is present on the sender side, which is performing an activity, on the receiving side, same object will be present. Of course, it will perform an opposite activity. Okay. So the objects involved in communication will be same at the both ends. Okay. But the activity what they are performing will be different, but they are the one and the same. Okay. So these are the two principles of protocol layering. We will go to the TCP/IP protocol suite. So totally in TCP/IP is the base model for today's internet. So today's internet functions based upon the TCP/IP model only. Okay. So there are four or five layers that are involved. So a concept of five layers is, if suppose the four layers is, if the first layer which involves physical layer and data link layer, if they are shown separately, then it will be five layer. If they are shown first layer and second layer together, then we say that the TCP/IP protocol involves only four layers. Okay, so totally we have the physical layer or the hardware layer, network interface layer, internet layer, transport layer, and application layer. Okay, so as I told, how many layers will be involved in the transmission that we have already seen. So only the end machines will involve all the five layers for communication. The intermediate layers which perform intermediate machines or components which perform only transferring of data or forwarding data, they will involve only those many number of layers. So for example, as shown in this diagram, the links are nothing but the switches. So from the sender side, data is transmitted to a switch. So in sender side, all five layers will be involved. In at the switch, only two layers will be involved because data transfer will be taking place within a network. So when the from the link, the data will switch, the data will go to the router. At the router, three layers will be involved. So why at the switch two layer and why at the switch three layer? Why at the router three layers is routers are connecting devices which will connect two different networks, whereas switches are within a network. Okay, so when you involve one or two networks, we need a router. So in such case, we need three layers, which involves the network layer also. And finally, the on the destination side, we involve the switch, and finally to the end machine. At the end machine, we have five layers that are involved. So this we'll see the individual functions of these layers, what each layer performs while transmitting the data. Okay. So coming to the physical layer here, the data will be converted into bits, and these bits they'll be sent out from the machine as signals. The signals can be either electrical or optical. Okay, so there are multiple protocols that are involved that performs this conversion task. So first, the protocol has to convert from bit into bits, and finally, and then from bits to signals. So this will be taken care by multiple protocols that are available. And next we have the data link layer. So data link layer will involve the transfer of data within a network. Okay, so from the originating machine or sender to the switch. So data has to be transmitted within the network. So this will be taken care by the data link layer. So whenever you are going to transmit data across the network, then we involve a router. that will be a different layer task. So right now in data link layer, it involves only two layers: physical layer and data link layer. Okay, so that will be performed in the switch within a network. So the major tasks that are performed in data link layer is here the data is referred as frames. So what is a frame is nothing but the individual bits are grouped together into frames. Okay, that's what is called as framing. And next we'll perform error, flow control and error control. So coming to flow control, so flow control is a concept where we are the sender, which is considered as a faster machine that is producing data, has to transfer data accordingly by knowing the available empty space on the receiver buffer. Okay, if there is limited space available, then the sender machine, even though it is faster, it has to restrict its speed of production and size of data. So by doing so, we avoid data loss. That's what called as flow control. And coming to error control, it is a two-step process where we are going to detect the error and we are going to correct the error if error is present. Okay, so here both flow control and error control is performed across two machines that are next to each other, node to node perform. They are performed node to node. Okay, so in this way they differ from the other layer, which we will be seeing shortly. So here the flow control, scope of flow control and scope of error control is between adjacent nodes. Okay, next comes the network layer. So network layer, when we want to communicate across the network, then the network layer will play its part, as we have seen in the diagram in the router. Okay, so when the source and destination are at different networks, then it involves the network layer. So network layer, the main task of network layer is it has to define the structure of data. And here in network layer, the data is referred as a packet. So what is the structure of the packet? So that will be defined by the network layer. And what type of addressing is required? So coming to addressing here, we need to know the destination machine's address to which we are going to transmit. Okay, so the addressing format will be defined by the network layer. And finally, there will be multiple paths between the sender and the receiver. So which path the packet should take or data should take to reach the destination will be decided by the routers. Okay, so these routers in turn will rely upon the routing protocols. The routing protocols will find out the best available path and they will be feeding it inside the routing table. And from the routing table, the router will come to know about the best path, and in that path, it will transmit the data. So, to give a general account, there are three tasks, major tasks that are performed by the network layer. The first one is it will define the structure of the packet, it will define the format of addressing, and it will perform the routing process. Okay, so these tasks are mainly performed by the major protocol that is present in the network layer, which is the Internet Protocol. So this Internet Protocol is a connectionless best effort service. Meaning for best effort services, meaning for connectionless is it will not establish a connection between the sender and the receiver. Okay, and best effort service, so it will try to deliver the data to the destination, and it not there is no guarantee for the delivery. Okay, so that's why it's called as best effort service. And there are also a host of other protocols that are available in the network layer to support the performance of IP. The first such protocol is ICMP, Internet Control Message Protocol. So this protocol will be used whenever there is a non-delivery of data. So if suppose for any reason, if a host cannot forward the data further, that particular host will signal failure to the sender with the help of ICMP protocol. Okay, and next thing is the Internet Group Management Protocol. So whenever a message transmission is taking place between a sender and a group in the sense a group of receivers. Okay, so in such cases, the Internet Group Management Protocol will play its part. Best example is our WhatsApp. In WhatsApp, we'll be transmitting a data to a group. Group will have a single address only, but the number of recipients inside the group will be more. Okay, so the single message that is received by the group address will be replicated to the number of recipients in the group, and accordingly, each recipient will receive a single copy of the message. And third, we have the dynamic host configuration protocol. So this dynamic host configuration protocol is used to automatically configure IP addresses to the individual host. So if the network is small, the network administrator manually can configure the IP address. Whereas if the network is huge, then there is very difficult for the network administrator to carry out the configuration process. Okay, so this DHCP will automatically configure IP addresses in each individual host. Okay, so that will be taken care by DHCP protocol. And lastly, we have the ARP protocol, address resolution protocol. So this address resolution protocol is majorly required for the network components to understand the address part. So usually, when we transmit the data will be in. I mean, when we fill the address will be in IP address format, numerical format. So this numerical format address is understandable to humans, but not to the components involved in computer networks. Okay, so we have to convert the IP address into a format that is accepted by the or understandable to the network components. So this ARP address resolution protocol will take in the IP address as input and will produce the MAC address as the output. So upon getting the machine address, the network components will understand the address and they will deliver it to the exact recipient. Our next layer is the transport layer. So coming to the transport layer, so transport layer is an end-to-end layer, just like the IP layer, but only difference is transport layer will provide guarantee to the service, to its service. Okay, so meaning of guarantee is it will assure the sender that the data has received by the receiver. How it assures? With the help of acknowledgements. So whenever a sender sends a data, the receiver will acknowledge that it has received the data. So this acknowledgement will be received by the sender. Okay, so that will be provided by the transport layer, right? And in transport layer we have two types of protocols. So each protocol is applicable for a particular type of service. So the first major protocol is the transmission control protocol. So where it establishes it is a guaranteed service protocol. It will establish a connection with the sender. It will transmit the data to the. It will establish the connection between the sender and the receiver. It will transmit the data, and finally it will break down the connection that has been established. So totally, data transfer involves three-step process: establishment of connection, transmission of data, and finally breaking down of the connection. And we have a guaranteed service in the form of TCP protocol. And next we have the user datagram protocol, which is similar to IP, that is a non-guaranteed service, a best effort service. For a data transmission to occur under UDP, all that is needed is the data and the recipient address. When these two features are available, that is the data and the address of the receiver, data can be transmitted. Okay, but data may or may not reach the receiver. So it is up to the higher layers to take care of the application to take care of the reception of data. If data is not received, the application has to ensure, I mean, has to instigate retransmission. Okay, the protocol itself will not go for automatic retransmission. Whereas in the case of TCP, if the data is not delivered, the protocol TCP will automatically initiate the retransmission process. Whereas in the case of UDP, the initiation will be taken care of by the application. So there are specific applications that require both these protocols features. TCP, whenever a application requires a guaranteed service, it will rely upon TCP. So there are certain applications that do not rely upon TCP, but instead they rely upon UDP. So all that they need is a transmission service. So the message may or may not get transmitted. So if the message is not transmitted, they'll go for retransmission by themselves. Okay. So, for example, the best example for user datagram protocol is short message service. So, SMS, which we use in our mobile phones, the message may or may not get delivered properly. But if the message is not delivered, again, will the user will retransmit it, not the protocol. Okay, the protocol will not initiate the retransmission. Only the user has to initiate the retransmission. Okay, we have a third type of protocol that is available in transport layer, which is called as stream control transmission protocol. So this particular protocol will combine the features of both TCP as well as UDP, right? So mainly it is used for multimedia type of transfers. Okay, now coming to the last layer, application layer. So as the name suggests, applications that are running on the computer will use the application layer to format the message or to draft the message using various protocols. So depending upon the type of application, different protocols will be involved. So if it is a mail, the email protocol will be involved. If it is a file transfer protocol will be involved. Accordingly, if you're going to browse if you're going to connect with the internet server, so it will be involving a web protocol, okay, like HTTP. So different protocols are there for different types of service or applications. The major protocols that are involved. Okay, so in what happens in actually in the uh, application layer is a process on the sending machine tries to communicate with another process on the receiving machine. So it is basically a process to process communication. Okay, So one process on the sender side communicates with other process on the receiver side. The major protocols which assist in this communication are we have HTTP protocol when we want to establish communication with the web server, and we have a simple mail transfer protocol when we want to establish a email connection between the email communication between the sender and the receiver, and third we have the file transfer protocol when we want to exchange files from one system to the other system will be depending upon this protocol, and we have a telnet and SSH secure shell. So whenever we want to connect to a system remotely, so we'll be using this terminal network protocols. And next we have the simple network management protocol. So whenever we want to manage a network, that is, if an administrator wants to manage a network, then he will be make use of this particular protocol. And next we have a domain name system. So domain name system, which is nothing but which will provide a mapping service. So whenever a user enters a name of the domain to which he wants to establish connection, the domain name has to be converted into IP address. So the mapping between the domain name and IP address will be maintained by the domain name system. Okay. So from the domain name system, we'll obtain the IP address, and to that IP address, we will establish the connection. So this is what about the layers that are present in the TCP/IP model. So basically, there are four different types of addresses are involved in TCP/IP. The first address, which is human created, human recognizable address, which is the domain name. For example, Yahoo.com, Google.com. These are all various domain names to which we want to establish the connection. Okay. And next we have the port numbers. So port numbers are nothing but whenever we open an application for communication, so this application will be running behind or is assigned a particular port number. Okay. So a port number, if a system wants to receive a data for a particular application, it will be delivered to the particular port behind which the application functions. Okay. The port number will receive the data from the port number. The data will be communicated to the particular application. And next we have the IP address. So IP address will identify a machine that is connected to a network. Okay. So these IP addresses are not enough for successful data delivery. Okay. So using IP address, we can identify the sender and the receiver. But for intermediate transfer within the network, we need the MAC address. So MAC address is the address that is recognizable by the network components. So these the MAC address only the uh, MAC address is the only address which the network components will understand. So the user entered IP address has to be converted into a MAC address with the help of address resolution protocol, and then only if the MAC address is obtained, the network components will deliver the data to the corresponding address. So totally there are four addresses that are involved in TCP/IP communication. Okay, so we have the domain name, we have the IP address, we have the port address, we have the MAC address. Okay. So multiplexing, demultiplexing, where each layer will generate its own data. Okay, and these data are multiplexed together into a single packet, and it will be transmitted to the as a single block. They'll be multiplexed. Multiplexing is many to one. So many layers within a system will generate their own data. All these data will be combined together into a single block. Okay, so that is shown here. If you see FTP and HTTP, they rely upon TCP and they generate data. Similarly, DNS and SNMP, they rely upon UDP and they generate the data. So these data together are combined into a single IP packet, and that IP packet will be transmitted. So when the IP packet is received by the destination machine, at the transport layer, we have different port numbers for these different protocols or different applications. Accordingly, demultiplexing will take place, and data will be separated, and it will be delivered to the corresponding application with the help of the port numbers. Okay. So next type of model is the OSI reference model. So coming to the OSI reference model, it was developed by International Standards Organization, and it was developed in 1984. Pretty well advanced. After TCP/IP model was accepted and deployed in the internet communication, this OSI model came into existence. So OSI model practically is not feasible because of various drawbacks, but still OSI model is regarded as the best source for the researchers. So the description that is given in the OSI model can be used for various research purposes by the researchers. So this OSI model also involves 7 layers. It also involves layering concept, but the number of layers is increased when compared to the TCP/IP. Here we have 7 layers. So if you see the single layer in the application in the TCP/IP, which is the application layer, is divided into 3 sub layers. We have application, we have presentation, we have session. So totally, There are seven layers that are involved in a communication between sender and receiver in the OSI model. So we'll see among these seven layers, the bottom four, that is physical, data link, network and transport. They are regarded as the network support layers. They are involved with the transmission of data across the network. And the upper three layers, that is, we have application, presentation, and session. So these three are called as user support layers. They involve with the generation of user data and interpretation of the user data. Okay. So coming to the functionalities of layers, we have first physical layer. So physical layer mainly is involved in the transmission of data. Okay, so data has to be converted into bit format, and the bit has to be converted into signal format, and that signal has to be transmitted. So it mainly requires physical interface and mechanic. Physical characteristics of interface and media. So what interface is required to transmit data inside the physical layer, and what media is required to transfer the data from the machine. And next we have bit representation. So what does bit 1 means, what does bit 0 means, so that distinction has to be created. And data rate, so data rate depends upon the medium what you're going to employ. So either it is a cable medium, that is wired medium, or a wireless medium. If it is a wired medium, what type of cable is involved, because each cable will deliver a different type of data rate, speed of data. Okay, so fiber optic will have more speed, and coaxial cable will have less speed, and finally we have twisted pair cable which will have medium speed. Okay, and next thing is synchronization of bits, so which involves the synchronization of sender clock and the receiver clock for proper delivery and reception of data. Line configuration, so we have two types of lines connections. We have point to point and multi point. And next we have physical topology. So there are four types of topology, among which one has to be selected for the network layout. And finally we have the direction of data flow, so which can be either simplex, half duplex, or full duplex. So all these design decisions are made at the physical layer, and accordingly network will be designed. Okay, and next comes the data link layer. So data link layer, data is represented as frames. Okay, so if you consider the physical layer, data is just bits, which doesn't have any meaning. So these bits are combined together. They provide an information. Okay, so that frames provide information, right? There are three major tasks that are performed in data link layer. The first and foremost one is the grouping of bits into frames. The next one is the logical addressing, where we convert the IP address into MAC address. And the third one is the flow control, so where we control the speed of the sender according to the space available at the receiver. And next is the error control, so where we'll detect the error in the data and we'll try to correct the error. If the correction is not possible, then data retransfer will take place. Next, we have access control. So network at a time only one system should be allowed to transmit the data. What if more systems simultaneously transmit data? So problem is collision will occur. So if collision is nothing but colliding of one system's data with other system's data, ultimately no data will be received. If at all received, it will be a corrupted data. Okay, so to avoid all these scenarios, we go for access control, where only one machine will be permitted at a time to transmit the data. So that will be taken care by the data link layer. Okay, and next comes the network layer. So in network layer, network layer will be coming into play when we involve the multiple networks. When the sender is in one network and the receiver is in another network, then we have the role of network layer. So there are two major tasks that are performed by network layer. One is the physical addressing, where we'll generate the IP address for each connected machine, and to this address will be delivering the data. Each machine connected in the network will have a IP address. And next we have the routing. So sender and receiver, between sender and receiver there will be multiple paths. So best path has to be chosen by the routing protocols, and the best path will be provided to the routers, and in that the routers will route the data through that best path. So these are the responsibilities of your network layer. And then comes the transport layer. Transport layer is regarded as the end-to-end layer, just like the network layer. So network layer, it is a best effort service. Okay, the service provided by network layer is a best effort service, not a guaranteed service. Whereas coming to transport layer, it is also a end-to-end layer, but the service provided by a transport layer is a guaranteed service. So guarantee will be provided in the form of acknowledgements. Okay, so here we have the services responsibilities of transport layer. The first one is the service point addressing. So coming to service point addressing, here when we say two computers are communicating, it is not actually the computers that communicate. It is one of the process inside the computer that communicates with another process in the another computer. Okay, so process to process communication is regarded as the service point addressing. So each process will be at the end of will be provided with a equipped with a port number. Okay, so to this port number only data will be received. Through this port number only data will be transmitted. Okay, for receiving and transmitting the data on a particular machine, we use the port address, which is provided by the port number. And next we have segmentation and reassembly. So here data is referred as segments. In network layer, data is referred as packets. In the link layer, data is referred as frames. In physical layer, data is referred as bits or signals. So coming to transport layer, where data is referred as segments. So these segments are nothing but divisions of data. Fragmented data are called as segments. So these fragments will not be transmitted, will not taking the same path while reaching their destination. Each fragment will take a different path to reach the destination, and ultimately there is a more chance that these segments may arrive out of order. So these out of ordered segments cannot be delivered as such. So they have to be regrouped, reassembled, and then they have to be delivered. So that will be taken care by the transport layer. And coming to the error detection, error correction, that is error control and flow control. So here the scope of this task, flow control or error control, will be between sender and the receiver. Okay, and next we have the session layer. In session layer, we'll provide or will establish sessions for the communicating parties. Okay, so in this session only two parties will communicate. So session layer, because of this reason, session layer is called as a dialogue controller. So dialogue is the information that is exchanged between the sender and the receiver. Okay, so it will tell when each machine has to communicate. Accordingly, the two machines will communicate in the allocated session duration. And also it is used for synchronization purpose. So synchronization, imagine we are transmitting a huge file between sender and receiver having 1,000 pages. So in between the transmission, for example, after the 500th page, the machine sender machine gets crashed. So when the sender machine resumes, we need to know whether we have to start the transmission either from page one or page 501. So if the session layer, what it will do is it will be helpful in creating bookmarks, checkpoints. So we'll be coming to know using the help of bookmarks and checkpoints what is the page that was successfully received, and accordingly we'll proceed with the next page. So that is the functionality of session layer. And next comes the presentation layer. The presentation layer involves with the syntax and semantics of the transmitted message. We know in networks involve heterogeneous systems. Each system will be composed of different type of processes, will be having different data structures, different interpretation for data, etc., etc. Okay, so all these heterogeneous systems will be combined together for using protocols. Okay, so here a sender transmits the data which will be in a local format, sender understandable format. So when the message is about to leave the system, the presentation layer will convert the local format of the message into a universal format. So the message will be transmitted in the universal format. It will be using the receiver's presentation layer. At the receiver's presentation layer, again this universal format will be converted back to the local format, which the receiver will understand. This process is called as translation. It will be performed by the physical layer. So it will be performed by the presentation layer. And next task performed by the presentation layer is the encryption. So encryption involves security. So when you want to hide the message that is being transmitted, we'll be using some encryption protocols. So using the encryption protocol, the message will be hidden and it will be transmitted. Okay. So next comes the compression. So compression, as it know, as the name implies, a huge message can be compressed to a shorter message, and we can easily deliver the shorter message to the destination. Okay. So it will increase the speed of delivery. And last comes the application layer. So application layer is a host of protocols. Okay, so each protocol will be used for a particular purpose. So the responsibilities of application layer, first one is the network virtual terminal. Imagine we have a network of heterogeneous systems, and this network has a printer. The printer has to accept the command that is sent by different computers for printing. So each is a different type of computer. Okay. So what happens here is the application layer will create a network virtual terminal of the system on the printer. Okay. The console of the that is nothing but the console of the individual machine is copied to the printer. The printer will interpret the command sent by the individual computer as a local command, and accordingly it will start printing. So this will be carried out. This activity will be carried out by the printer for each command that it receives from different computers. Okay. And next thing is the file transfer access and management, where the files are exchanged between computers with the help of specific protocols, for example, file transfer protocol. And next we have mail services, where the mails are exchanged between two parties with the help of simple mail transfer protocol. And next we have directory services, where distributed data will be stored in different servers, and these data will be updated, retrieved with the help of protocols. So these are the various services that are provided by the application layer. Okay. So what we have seen is basic introduction about the networks, the components of data communication, and then we saw the different representation of data, different types of line configurations, and different classification of networks, different topologies, and the reference model for today's internet, which is TCP/IP. And finally, we have seen about OSI model. Okay. So among this, the OSI model is only descriptive. It is used by researchers for carrying out their research to discover new protocols, new services. We use the OSI model. OSI model is not practically feasible because of various loopholes. So it is not materialized. Thank you.